11.1 is angle measures in polygons. So the first type of angles that we're going to talk about are interior angles. So these are the angles that are on the inside of the figure. So the first one we said was a triangle, and we all know that a triangle has its angles add up to be 180 degrees. So that's no surprise to us. So that was 180, and you guys tried that with your protractors, and you saw that it was true. I'm sure you guys probably had like 181, 179, but that's just, you know, error of the eye. So the next one. So here's the trick that we're going to do. So you're going to take a line from any vertex and connect across. So we're going to draw in all of the diagonals. Not all of the diagonals possible, but some of them. Hang on just a second. Okay. So we drew this diagonal in, and if you think about it, all of these angles in this first triangle, they add up to be 180, right? And all of the angles in this second triangle, well, they add up to be 180 as well, right? So we have two 180s, and two 180s ends up being 360, right? So it's 2 times 180, which is 360. Well, when we draw on the diagonal on the next one, so only going from one vertex, so I go across and I go across again. So how many triangles are formed now? 3 of them. So now we have 3 triangles, and all of those angles in each triangle make 180. So I have 3 of the 180s, and 3 180s ends up being 540. And then on this last one, we have from one diagonal, we draw on one vertex, we draw on 3 diagonals. So now we have 4 triangles, and 4 times 180 is 720. So let's see if there's a pattern. Well, we can see there's a pattern, right? So this had 3 sides. It was a triangle, and we had 1 of the 180s. This one had 4 sides, and how many 180s did it have? 2 of them, right? The next one had 5 sides, and how many 180s did it have? 3 of them. And the last one had 6 sides, and it had 4. So question, what if I had 12 sides? Yeah, 12 sides, we would have 10 times 180. So we would get 1,800. Okay, so do you see the pattern, how this works? So there's obviously a formula. So in the box down there it has the formula. But let's talk about what these are called. So you guys know that a triangle has 3 sides. A quadrilateral has 4 sides. A pentagon has 5, and a hexagon has 6 sides. So if we have n number of sides, we call it an n-gon. And the number of triangles that are created for each of these, if I had 3 sides, I have 1 triangle. If I have 4 sides, I had 2 triangles. If I had 5 sides, I had 3, 4. So what about if I had n sides? N minus 2, perfect. And the sum of those interior angles was going to be 1 times 180, which was 180, right? And we see the pattern, 2 times 180, which is 360, and so on. So we have 540, 720. So what if I have n sides? Not n times 180, tricky, tricky. N minus 2 times 180. So that's our formula, n minus 2 multiplied by 180. Or you might write it as 180 times n minus 2 if you want. But usually we write it in textbooks as n minus 2 times 180 because it comes from that process. So that's the sum of the interior angles. So I'll say S equals. All right. So what about these names? So we said triangle, quadrilateral, pentagon, hexagon. What about 7? Everybody always gets this wrong. They always say septagon. It's not septagon. Do you guys know what it is? No. It's a heptagon. And 8 is octagon. Nonagon, that's my favorite. Isn't that a fun one to say? Nonagon. 10. Decagon. That's right, dodecagon. Because it's a decagon plus 2, do. So everybody always hates these because they're like, wait, it's kind of like a calendar. Like we have December, November, October. Have I told you this story before?
Yeah.
Yeah. So do you guys remember why that's true? Why is it 2 off? Who got added in there?
Oh, August was added in there.
Augustus and Julius Caesar. August and July. So they messed up our bases because we know that oct means 8, right? Octopus has 8 legs. We know that December, well, that doesn't help. But like, what's decade, right? That's a stem for 10. So they messed it up. I don't know. All right, so let's see. The sum of the interior angles of a hexagon equals what? So if we have a hexagon, I guess we have that on the front page. It's not really anything hard. But we're going to do 6 minus 2, and we're going to multiply by 180. So we're going to have 4 times 180, which is 720. So number 2, how many degrees are there in the sum of the interior angles of a nonagon? So nonagon, we do 9 minus 2 times 180. So we have 7 times 180. Do we have that?
1260.
What is it? 1260.
1260.
Good, thank you. I guess I could put degree marks. It doesn't matter though. Okay, so let's go the opposite direction. So it says if the sum of the interior angles equals 900, how many sides does the polygon have? So it's saying we have 900 is equal to n minus 2 times 180. So I could distribute the 180 if you want to, or I can divide the 180 over. So let's say we just divide it out to begin with. So if I divide by 180, I get 5 on the left side. So 5 equals n minus 2. So I get n is equal to 7. So it would have to be what kind of shape? A heptagon. Yeah. Do you guys see why people always say septagon? Because I think September is the 2 months off thing. All right. So you might have things, so I guess same idea here. So it says, what is a polygon called if the sum of its interior angles equals 1440? So we do 1440 equals n minus 2 times 180 because we need to figure out how many sides it has. So when I do 1440 and I divide by 180, sorry, I get 8 equals n minus 2. So n is equal to 10. So what is it called then? Decagon. Good. Does this make sense? Yeah, it's not too bad. So we might have something where there's already a picture, and it's like, oh crap, what do all these angles add up to be? Well, just decide what kind of shape it is. So how many sides do I have? Well, if you can't count the sides, you can also count the angles. So I have 5 angles, which means I also have 5 sides. So if this has 5 sides, it's a pentagon. And a pentagon is going to add up to be 5 minus 2 times 180. That's 5. And that's going to be the sum of the interior angles. So I'll write S equals. So 3 times 180 is 540. So the sum of all those angles has to add up to be 540. So now we take all these angles and we add them together. So we're like, okay, x plus 114 plus 105 plus 102 plus 135 equals 540. And we can solve for x. So we do our 540 and I just subtract all those out. So I get x equals 84. Okay, do these make sense? All right, so now we have another one. So now you definitely want to use a straight edge. So draw a convex triangle, a quadrilateral, and a pentagon in the space below. And then what are your conclusions? So now we're going to talk about what's called the exterior angles. So if I have a triangle, exterior angles would be if I extended my line in one direction. So if I start extending this way, so it's going to be exterior angle, exterior angle, exterior angle. So find what like all 3 of those angles add up to be. And then do the same thing for a quadrilateral. So again, try not to make it like a square or anything. And then a pentagon. Okay, so you're going to extend, extend, extend. You never want your exterior angles to like cross over the last one. So do you guys see how I kind of extended in that certain way? I didn't want to extend so it was this way. So it made like an X shape. Okay, so go ahead and try that. You guys didn't do it. All right, so basically, yeah, these three angles should add up to be 180 degrees. Oops. These four angles actually also add up to 180 degrees. And then these exterior angles here, surprise, they add up to be 180 as well. I don't know how to make these different. So they add up to be 180 as well. Okay, so exterior angles aren't like the interior angles. So the interior angles, they all added up to be like bigger and bigger and bigger, like 180, 360, 540, and so on. But exterior angles just add up to be 180 every single time. So their sum is going to be just 180. So don't get the S's confused when I write like S equals. Okay, I always imagine like moving these angles in towards each other, like when I moved this angle down and this one over, they kind of made that circle. Or not a circle, but they made a, not, why am I saying 180? Oh my gosh, I just got this totally wrong. It makes a circle. It's 360, just kidding. This is why I should not deal with my cross-country drama while I'm trying to teach. All right, so 360, 360, 360. It makes like a circle when you add them all together. So these make 360. Did you guys get 360 when you were adding them together? Yeah. All right, so these four angles. So these are all exterior angles. They're on the outside of the shape. So that means that 2y added to y added to 2y added to y has to equal 360. So we get 6y equals 360. So y equals 60. All right, so number 2, it says find the measure of the exterior angle of the regular hexagon. So a regular figure has all congruent sides and all congruent angles. Okay, so all the sides are the same, all the angles are the same. So that means all of these exterior angles, they're all going to be x, right? So how many of those x's will I have? 6. It's a hexagon, right? So that means that 6x equals 360. So x is equal to 60. Okay, so the next one is some kind of polygon. How many sides does it have? Yeah, it's a pentagon. It has 5 sides. And it says the measure of each exterior angle of a regular polygon is 40. How many sides does the polygon have? Oh, I guess I was looking at the picture for number 4. That was pentagon. So if each angle makes 40 and they all add up to be 360, then how many of them would there have to be? It would have to be 9, right? So if each one is 40 and we have n of them and all of them add to be 360, then we divide out, we get 9. So that would be a nonagon, my favorite. But number 4 is a pentagon, so that means 7a added to 2a added to 3a added to 2a added to 6a has to equal 360. Now I messed you guys up. You're all going to think it's 180 every single time now, aren't you? So it's going to be, let's see, 10 plus 10. So let's do 20. A equals 360. So A equals what? 18. Good. And then you could find all those angles by plugging A back in. Does this make sense? Do you guys get the exterior angle? All right, so let's kind of skip through. So let's say we mix them up again. So you got to be able to like mix them up and not just do only interior, only exterior. You got to be able to go back and forth. Okay, so let's try like 6C. So it says find the sum of the measures of the interior angles. So remember, interior is the n minus 2 times 180. So if we have a dodecagon, it's going to be 12 minus 2 times 180. So 10 times 180 is 1800. Okay, so go back and forth between interior and exterior. Don't just get like ingrained, oh, I'm only doing interior. You could have them mixed in together. That's what's tricky about these sometimes. All right, how about number 8 and 9? Let's do those. So it says you're given the measure of each interior angle of a regular n-gon. Find the value of n, so the number of sides. So this is each interior angle. Now that's tricky. And we're using the word regular again, so that means all the angles are the same. Okay, what was the sum of the interior angles? How did I find it? What formula? N minus 2 times 180. Now if I say each interior angle, this is different. So what if I had, let's say, a hexagon? If I found the sum of all the angles, I would do 6 minus 2, so 4 times 180, and I would get 720. So if I knew that I had a hexagon, a regular hexagon, where all the sides and all the angles are the same, pretend my drawing's better, and I knew that all of them added up to be 720, would I be able to find each one? Yeah, so if I had a hexagon, and I knew every single one was the same, and they all added up to be 720, how would I get each one? I would divide by what? 6, right? I would divide by the 6 angles that we had. I divide by 120. So what's our formula for each interior angle? Well, the sum of all of them was n minus 2 times 180. What do we do to get each one? And how many sides do we have? If I had n minus 2 times 180, I have n sides, right? Does that make sense? You divide by the number you have. So that's what we're doing here. So we're saying 108. We're taking our number of sides minus 2, we're multiplying by 180, and we're dividing by the number of sides we have. And when we do, we get a total of 108 degrees. Okay, so we multiply the n over, so I get 108n. And I could multiply the 180n. Let's go ahead and do that. So I get 180n minus 360, right, distributing this. And I can solve it out. So if I subtract the 180 over, I get negative 360 equals negative 72n. So when I divide 360 by 72, I believe I get 5, right? So I get n equals 5. So that means there would be 5 sides. Okay, so try letter C. I didn't give you very much room for these. So we multiply the n over first. So we get 144n. Distribute that 180. Subtract the 180n over. So I get negative 360 equals negative 36n. And then divide. So I believe we get n equals 10 on that one. So it's a decagon then. Does that make sense how we set those up? So it's slightly different. And then same thing for number 9. So it says you're given the measure of each exterior angle. So if we're talking about each exterior angle, what was the sum of each angle, or each exterior angle? If I added all the exterior angles together, what did they add to be? 360. So if I talk about each one, I need to divide by the number that I have. So 360 divided by n. Again, it says regular. So if I have 360 divided by n equals 90, all of those exterior angles, each one is 90 degrees. How many of them would there be? 4, right? Does that make sense? 360 divided by 4 equals 90. If you didn't know how to do that, you could multiply the n over and then divide by 90. You get 4 equals n. How about C? Can you guys do it in your head? 360 divided by n equals 30. What do you divide 360 by to get 30? N equals 12. So it's 12 sides. Okay, so be careful. So some of them talk about the sum, some of them talk about each exterior angle or each interior angle. They can be a little bit tricky. All right, and the last thing I want to show you, so we can skip this problem. But the thing I always tell my geometry students is that you can you can think through this without knowing the formulas. Okay, especially when you have these regular shapes. Regular means all those sides are congruent, all the angles are congruent. So let me show you an example. So let's say I had an octagon. Okay, I'm really bad at drawing octagons, but I'll try. So everybody kind of sketch this out along with me. So hard to get it to be like regular. Okay, so here's my octagon. Let's say I want to know the interior angles and the exterior angles of the octagon. And you're freaking out. You're taking the SAT. You're like, I don't know how to do this. I don't remember all those formulas for geometry. And that happens a lot to students because a lot of times you take geometry, like in your freshman year or your sophomore year, right? In your case, before your sophomore year in the summer, or before your freshman year. So let's say you're a junior and you're taking the SAT and you're like, I don't remember anything that Mrs. Cox taught me in those 6 short weeks of geometry. Okay, that's okay. You can always figure it out. So here's what I tell people to do with these regular shapes. Draw in a central angle. That central angle is the key to everything. You don't have to know all of those formulas. You can get it from just that central angle. So let's use our smarts. How many angles, like how many degrees go all the way around the center? 360, right? How many of those central angles will I have that will all be the same? So if I drew these in, how many would I have? I'd have 8 because I have an octagon, right? So if I wanted to find one of those central angles, I do 360 divided by 8. And I get 45. So I have a little triangle where I have 45 degrees, and these sides are the same. Are you able to get these angles right here? How? Yeah, 2x plus 45 equals 180. So we're going to do 180. We're going to subtract out the 45. We get 135. And we divide by 2. So together those two angles make 135. So each one is 67.5. So what is an interior angle? Here's what an interior angle on this shape looks like. What is the interior angle add up to be? Or what is each one? It's 135. It was what 2 of those blue angles that I drew on was. Does that make sense? Okay, tricky question. What about an exterior angle? Something like right here. So I don't have to draw it there. What if I drew it right next to that 135? You guys would all know then. It's 45. Do you guys see it? Because it's going to add up to 180 with that 135 that we already have. So we have that 135 right here. This one ends up being 45. Okay. Let's see if there's a pattern. So let's say I drew a hexagon instead. So if I drew a hexagon instead, and I talked about its little central angle there, what is this top one? 60, right? Do you guys see it 60? So what is each of these angles, the blue angles? They're both 60. They add up to be 120, right? So I get 60 and I get 60. So that means this whole exterior or this whole interior angle is 120. It was 2 of those 60s, right? It was the 2 added together. So then what's the outside? 60. Okay, in both of these problems, the exterior angle, 45, was the same as that central angle. Do we think that's always going to happen? I don't know how to draw a heptagon, but I'm going to try my best. It's not easy. It's definitely not regular. So what if I had 7 sides? I'm really struggling. I cannot do it. How do we draw a heptagon? 1, 2, 3, 4, 5, 6, 7. Okay, so let's say I have 7 sides. Clearly not regular, but we'll pretend it is. We would do 360 divided by 7, right? So in here, it's the lovely 51.428 something, so 429, we'll say. So if I did 180 minus that number, I get 128 something. And divide by 2, I get both these angles. I get 64.286 for each of those. So if I multiply by 2, that's how I get the interior angle. That's how I get this. So that's back to that 128 number, 128.571. So if I subtract from 180, the magical number I get is 51.429. Isn't that what I just had originally for my central angle? So you could even skip all this process, and you could say, oh, my central angle is always the same as my exterior angle in a regular polygon. And then you can get the interior angle because it's supplementary. Exterior angles and interior angles are always supplementary. Do you guys see this? So be smarter than the things like the SATs and so on. Think about the process, not all of the formulas. If you're just a student that just memorizes things, you're not going to be successful in things like that. I mean, you probably will be, but you're not going to be as successful as you could be because it's about logic skills, knowing how to find those answers.